So in this episode of 1 Minute Solutions, this is a two-part question on the 2020 PSAT exam. Let's see what it's all about. Okay, there's this big blurb over here with this table. Honestly, as a test-taking strategy, if you're comfortable with it, I would not recommend reading all this. Just pay attention to the table and then just glance at, oh, there's a formula here we might need, and then read the question and then come back to this blurb if you need to. Okay. Why do I say that? This is like in the reading comprehension section where they tell you to read the question first and then go back to the passage to try to answer the question. This is very similar here actually, because a lot of this information you might not need, or in the case of number 15, you don't need any of these two paragraphs actually. Okay, so let's jump to number 15 first. It says the mean distance of Mars from the sun is k times the mean distance of Mercury from the sun. Which to fall is closest to the value of k? So you can, just from this question, we can set up an equation without having to read any of this. You'll have to look at this table to plug in some values, but you don't need to read any of this. Maybe if you need to help understanding what this table is, then go ahead and read it by all means. But if you are comfortable with it, read the question first and then come back to the information over here, this blurb over here. Okay, so as I was saying, we can translate this sentence, this first sentence in the question 15, into an equation, okay? The mean distance of Mars, which now let's look at the table. That's 227.9, mean distance from the sun. So this is mean distance of Mars from the sun. That's 227.9 is equals, excuse me, k times the mean distance of Mercury from the sun. So k times mean distance of Mercury from the sun. That is 57.9. What's the value of k? Just solve for k, divide by 57.29 on both sides. K is 3.94. Answer is D. Okay, so this is a classic example of you don't need to read all this stuff. Okay, now for number 16, you might actually have to read it to understand it, unless you know physics and you know about weights and versus mass. Good if you know it, because you don't need to read the stem. But um, let's see what 16 says first of all, and then we'll come back to it. If Jing would weigh 200 newtons, 200 N, if you don't even know what newtons is, this is N, it says it over there, but let's assume we don't know it, 200 N on the surface of Mars, which is falling as closest to what her weight would be on the surface of Venus. Okay, so now if you're totally lost as to how to use this table and how this 200 newtons comes into play and all that, let's start reading. Okay, this describes a table, so maybe let's not read that, okay? Because it gives us the headers and all that. Now, what about the second paragraph? For an object with mass m kilograms, the weight W in newtons of an object on a planet's surface can be found using W equals ma, where A is acceleration due to gravity at the planet's surface. So notice how I'm not even even though I'm reading out loud, I'm not reading every single thing. You can quickly pick up the pieces, hopefully, with enough practice, okay? If an object is moved from, this is the key point, actually. Let's pay attention. If an object is moved from one planet to another, the object's mass does not change, but its weight does. So if you have this concept of weight versus mass from a physics class or science class or something like that, you'll understand how to solve this question. If not, we have to internalize this very last sentence first, okay? And we got a problem solved from here. So as I'm saying right here, key point, mass does not change, but weight does. Okay? So it's asking what Jing would weigh on Venus versus Mars. So what's the commonality? It's the mass. Okay? So if we can find Jing's mass, then we can find the weight on any planet. That's the whole idea here. Hey, by the way, the SAT categorized this as intermediate. I would possibly argue that this is more level 3, so difficult, because you have to think a little more on this, and you need to have this conceptual understanding of mass versus weights. that I would categorize a little harder, all right? That's just my opinion. But anyway, so let's find the mass. So this is how I notated it. You can notate it however you want. This is just for me to explain. The weight on Mars is equal to mass times the acceleration on Mars, acceleration to the gravity on Mars, okay? So they give us weight is 200, okay? We're trying to find what mass is. Do we know the acceleration due to gravity on Mars? So this is where it gets tricky for, I would say, the average students, okay? They don't give it to us, but we have to do it symbolically, okay? We know the acceleration due to gravity on Mars is this, we look at this column over here. On Mars, it's 37.7% of what it is on Earth. So I wrote that over here, 0.377 times acceleration Earth. Okay, so we symbolically solve for m, the mass. Mass is 200 over 0.377 A Earth, okay? And now we can go find the weight on Venus. The mass is the same. We found the mass right here. The acceleration due to gravity on Venus, well, on Venus is 90.7% of the acceleration due to gravity on Earth. So we plug that in, okay? 0.907 A Earth. Notice the A Earths cancel, okay? So you get a numeric value of 481 if I put it in the calculator correctly. Okay, so the best answer is C. That's the closest one. Okay, so again, the key points are you have to understand this last sentence. And that's why, excuse me, if you know this concept, then you might not have to even read all this. But if you don't know this concept of mass versus weights, then you got to read this, at least the second paragraph. Okay. And then the other challenging part is A Earth is not given, but it doesn't matter. Everything's relative to A Earth. So we can solve for things symbolically, and then things will cancel when you like plug into another equation. Okay. All right, that's it for this video. Hopefully it was helpful if you got stuck solving this, if you got a hold of this practice test, really past test. Otherwise, hopefully this was helpful if you're seeing this new as well.